Welcome to the DIY Honda Garage channel. The diagnostic trouble code P0533 is specifically related to an issue with the AC pressure sensor circuit, indicating a high voltage reading. This can occur when the voltage detected is 4.75 volts or higher, leading to improper air conditioning system performance. The AC pressure sensor plays a crucial role by monitoring the refrigerant pressure necessary for the proper operation of the HVAC, heating, ventilation, and air conditioning system. This sensor is typically located in the engine compartment, connected to the AC system. Correct functioning is vital for the accuracy of the HVAC control module, and any faults must be diagnosed accurately to ensure the vehicle operates optimally. Be sure to document all data, including freeze frame data and any snapshots, prior to beginning the troubleshooting process, as these can provide important clues to the underlying issue. The AC pressure sensor is the primary component affected when DTC P0533 is triggered. It is designed to monitor the refrigerant pressure within the air conditioning system, relaying this information back to the engine control unit, ECU. The ECU uses this data to manage various functions, including compressor engagement and system performance optimization. Typically, the AC pressure sensor is located in the engine compartment, easily accessible for diagnostics. Any failure in this circuit can lead to incorrect pressure readings, impacting the entire cooling system function. Understanding this relationship is essential for effective troubleshooting and ensuring continued vehicle reliability. When diagnosing the P0533 code, several potential causes should be considered. A faulty AC pressure sensor is a primary suspect, as it might be providing inaccurate voltage readings. Additionally, wiring issues, such as worn insulation or broken circuits in the PD sensor or SG6 lines, can lead to an increase in voltage detected by the ECM. If the wires are intact, the problem may lie in the engine control module, ECM, which could require software updates or substitution with a known good unit for testing. Each of these areas must be thoroughly checked during troubleshooting to identify the root cause of the error. Symptoms associated with DTC P0533 typically manifest through various air conditioning malfunctions. Drivers may notice a lack of cool air emanating from the vents or inconsistent temperature control within the cabin. This occurs because the AC system relies on accurate pressure readings to function correctly, and an error in this system can lead to unintended performance issues. Additionally, when the fault is detected, other DTCs may be present, aggravating the situation and further complicating diagnostics. Recognizing these symptoms is crucial for timely and effective resolution of the problem. The first step in troubleshooting DTC P0533 involves validating the initial problem through operation checks. Start by starting the engine and allowing it to idle. Once the engine is running, switch on the blower and the AC as well. This set of actions prepares the system for a check of the AC pressure sensor's output voltage through the Honda Diagnostics System, HDS. Pay close attention to the voltage displayed for the AC pressure sensor in the data list. Ideally, it should read about 4.75 volts or more. If it does, the failure is confirmed, and you should proceed to the next troubleshooting step. If not, consider the possibility of intermittent faults and check for loose or corroded connections at both the AC pressure sensor and the ECM. In the second troubleshooting step, you'll focus on the AC pressure sensor itself. Start by turning the ignition switch to the lock position, ensuring that the electrical systems are completely shut down before you proceed. Next, disconnect the AC pressure sensor's 3P connector. To test the sensor's functionality, use a jumper wire to connect terminal A, number 1, black wire, to terminal B, Number 2, light green wire on this connector. This essentially bypasses the sensor and provides the system a direct line to evaluate its output. After connecting the jumper wire, turn the ignition switch to the on position and recheck the AC pressure sensor voltage using the HDS. If it shows approximately 4.75 volts or more, proceed to step 3. If not, replace the AC pressure sensor and verify the repair. The third troubleshooting step will help you evaluate the power and ground supply lines connected to the sensor. Begin by turning the ignition switch back to the lock position. Then, carefully remove the jumper wire you set up in the previous step. Next, turn the ignition switch to the on position again to power the system for the next test. Measure the voltage between test points as specified. Connect one multimeter probe to the AC pressure sensor connector number 1, black wire, and the other probe to connector number 3, red wire. Under these test conditions, you should detect a voltage reading of about 5.0 volts. If you do, move on to troubleshooting step 4. If you do not, return to the earlier steps to further check the PD sensor or SG6 wiring for potential faults. The fourth step involves a continuity check for the PD sensor wire, which connects the ECM with the AC pressure sensor. First, ensure the ignition is in the lock position. Then, jump the SCS line using the HDS to engage the required diagnostic controls. Next, disconnect ECM connector A, which is a 49-pin connector for the ECM located under the dashboard. Once disconnected, check for continuity between the specified test points, the ECM's pin 27 light green wire, and the corresponding pin at the AC pressure sensor connector. This test will confirm whether or not the PD sensor wire has continuity. If yes, the wiring is intact, and you should consider updating the ECM software or substituting with a known good unit. If no, you will need to repair any identified open circuit issues found in the PD sensor wiring. For the fifth troubleshooting step, you will perform another continuity check, but this time focusing on the SG6 line. Begin by turning the ignition switch to the lock position to ensure the system is completely shut down. Use the HDS again to jump the SCS line, allowing the tool to communicate adequately. Disconnect the ECM connector A, 49P as in the previous step. Now measure continuity, but this time between test point 1, ECM connector pin 10, black wire, and test point 2, AC pressure sensor connector 1, black wire. With the ignition locked, you should expect to see continuity. If this is the case, the SG6 line is functioning correctly. You may then consider updating the ECM software or swapping out the ECM for a known good unit for testing purposes. If no continuity is detected, you will need to address an open circuit issue somewhere in the SG6 wire. To conclude the troubleshooting process for DTC P0533, you must verify all repairs made. Start by turning the ignition switch to the lock position and ensuring that all previously disconnected connectors are properly reconnected. Following this, turn the ignition to the on position without starting the engine and reset the ECM using the HDS diagnostic tool, completing the initial system checks. Implement the ECM idle learn procedure before starting the engine to allow the system to recalibrate. Once idling, turn on the blower, followed by the AC switch, and then use the HDS to check for any pending or confirmed DTCs. If DTC P0533 reappears, thoroughly inspect for loose terminals or corroded connections at both the AC pressure sensor and the ECM to ensure electrical integrity. If there are no issues found and no pending DTCs present, wrap up the diagnostic process with confidence. Preventive maintenance is essential for prolonging the life and functionality of your vehicle's AC system, especially concerning issues leading to DTC P0533. Regular inspections of electrical connectors, including those connected to the AC pressure sensor and ECM, can prevent failures caused by corrosion or loose connections. Additionally, routine checks to ensure that the AC pressure sensor is operating correctly help in preventing premature wear or malfunctions in the HVAC system. Keeping the ECM software up to date is another crucial aspect. Software updates often enhance vehicle performance and rectify known bugs. Maintaining these practices not only offsets potential repairs, but can also elevate overall comfort and vehicle efficiency. In conclusion, effectively diagnosing and addressing DTC P0533 necessitates a methodical approach as outlined in the previous steps. Focus on specific voltage readings is critical. Understanding the importance of both the AC pressure sensor and its associated wiring can simplify the diagnostic process. Regular checks and necessary repairs not only help resolve immediate issues, but also improve overall vehicle reliability. Implementing preventive measures such as maintaining clean and secure connections and ensuring updated software will help you avoid recurring problems in the future. Ultimately, by following these guidelines, you can ensure your Honda Civic continues to perform with efficiency and reliability. Please like and subscribe to the channel. See you next time.